everyone. Today I will briefly introduce the assignment tool. In order to get to the assignment 2 page, you need to go to the assignment tool and download the PDF from it. And then you open the PDF, you will find there are 4 tasks overall. There are task 1, task 2, task 3, and task 4. I will introduce each of them briefly, and then after that we can take a look at of the skeleton code. And if you guys have any questions, you can post it in Piazza and we can discuss after that. So the task 1 is to implement your first search algorithm. In the search algorithm, given a query, you need to rank each document from a corpus, and this function fq_doc is a formula you need to implement by yourself in Java or Python. We recommend to use Java, but if you are not very familiar with it, you can use Python instead. And the descriptions of the formula and how to calculate it is described here, and you can take a look at it by yourself. Basically, it's a transformation of TF-IDF model. And after that, if you implement it successfully, given a query, you can generate a ranking list of documents and save your code as a name here, easysearch.java. And task 2 is to test your search functions with track topics. So the task 2 is to test your easysearch.java, whether it's work or not. And we use track topics. The file is also in Canvas, and you can download it by yourself. We can take a look at of the files here, and it contains multiple fields. The first one, the 2 fields we need to use as input query is the title and description. For each track topic, we need to have 2 queries. The short one is the title, and the long one is the description. So for each topic, you need to generate 2 document ranking lists. One is for short query, and the other one is for the long query. And you need to store the top 1000 search results for each query in a format like this in the below, because this one is a standard track output format. We need to use it for evaluation later on. And the format is, I will introduce the format in the later videos, and we can ignore from here. And remember, you need to store your code in search track topics.java. And the task 3 is test other search algorithms. Remember, task 1 and 2, you implement yours like a TF-IDF model. And in this task 3, we use the embedded algorithms in Lucene. There are 4 embedded algorithms you need to use. They are all of them are classic language models. You just need to follow the skeleton code and given a query, rank all the documents based on the existing models embedded in Lucene. It's very easy, and we can take a look at the skeleton code in later videos as well. And in the end, you need to generate ranking list for both short query and long query. Short queries, remember, is the track topics title, and the long query is the description field of the track topic. And remember, you need to store all your code for that in a compile algorithm.java. And the task 4 is the evaluation. After you generate the ranking list for your own algorithms and for other classic models, you need to evaluate how accurate your ranking result is. And we used track evaluation tools here, and you can download it in this page. In next video, I will introduce how to use this tool. It's very simple, and basically you just need to type a command in the terminal, and then they can automatically generate the result. That's the reason why you need to make your output files follow that format, because only in that track format the track tools can work properly to generate evaluation result. And in the end, you will have all these evaluation metrics here at precision at 5, precision at 10, recall at 5, recall at 10, MAP and NDCG for both short query and the long query. In the end, you need to fill up all the tables and report it to me and submit to GitHub. And that's the 4 tasks for your assignment 2. And hope you can enjoy it. And for the details, we can discuss in the later video.